Okay, we are moving right along with shakedown and debugging, and at this point we've already done a good, thorough, dry run of our program on either a PLC or an emulator. We've tested every single function, every single alarm, every mode, every status, every display, every indicator. We've tested everything in our program that we can to make sure everything is working as well as it should, exactly as desired. But we are not out of the woods yet. The next thing that we're going to be getting ready for is to test our program on an actual live system with inputs and outputs hooked up to the PLC. And before we do that, we need to make sure that electromechanically the machine is sound. We've already tested the program. We already know it works. We already know it's controlling the way that it should. But the next thing we need to make sure of is that the machine itself is wired correctly, that all the parts that we got from the manufacturer actually work, that nothing got damaged or broken in shipping. So when we come to our panel, one of the first things we want to do is do some I/O point-to-point checks. So here's a typical control panel, and it might be laid out such that we have the PLC, terminal strips, relays, all readily accessible for us to get to with a multimeter. And maybe this isn't even something that a programmer needs to do. This can also fall to an electrical engineer, a panel builder, maintenance personnel, startup personnel. That depends, but this needs to happen before the system goes live, even for testing. So we need to get into this PLC, get into this control panel, and we need to start checking electrically our connections between each of our I/O modules on our PLC and the actual physical input and output devices that exist on this machine. We need to make sure that everything is wired correctly, that everything's going to be able to exchange signals. We need to look at wiring and make sure we don't have voltage signals running past high current wires that are going to induce noise into our lines and cause us to get bad readings. We need to check all of our valves. We need to check our motors for direction of rotation. We need to make sure that nothing is stuck, that everything is wired correctly, that everything works. Once we've tested all of that by manually energizing relays, using our meter to test signals to check continuity, then we're ready to load our program onto that system, turn it on, and start testing it with everything live, up and running.